public PhD defense. This is, of course, a very special day for our candidate. This is like the last step, the last exam, because it is an exam. Technical problem. Okay. So it is an exam after all, but we expect everything will go fine because we had a very good private defense. And because everything was going very well at the private defense, we're here today for this public event. So it's nice to see again some people in the room to join us today. But obviously I also want to welcome the people who are online, who are watching on the live stream, and join us this way for this event. And especially our two external committee members, Professor Siguro Shiba from the University of Tokyo and Tim Felgentreff, from Oracle Labs, Germany, and they are participating in this event online. So they will also be involved in the deliberation afterwards. I, of course, also want to welcome or introduce the promoters of our candidate, so Wolfgang de Meuter and Yuri de Koster, both professors at the Soft Lab of this university, and our emeritus, Theodont, is also here for evaluating this work. So he was also heading the Soft Lab in the past. And then we have Christine Hout, also from this university, from ETRO department, so the engineering faculty, and I myself, on the way, I'm heading the AI lab of this university. So the procedure is as follows. Humberto will first give a presentation, so that you all know what he has been doing the past years. Then I will invite the committee to ask some questions to him, and then I will also invite the public to ask a question to Humberto in case you have a question. Afterwards, we will go to the deliberation room. I'm not so sure where this is. And then shortly afterwards, we will come back to announce the result. But first, Humberto, please go ahead with your presentation.
Okay. You can take that.
There are people waiting.
In the waiting room. Security. Yeah, okay, so now everyone should join. Just a second. Can you hear me well?
Yes.
The back? Okay, well, good afternoon everyone, and thanks for being here today, physically, and also for those that are following online. In the next 45 minutes, I will give you a summary of the work that I have done during my PhD. In this dissertation, we propose a software engineering approach for orchestrating actors. in the context of cyber-physical systems. By orchestration, we mean the coordination of the action that a group of actors can do, and in this context, we particularly focus on the smart home domain. This domain is an interesting and growing domain where a group of smart devices collaborate with each other in order to improve the life of the inhabitant of a house. We envision that these smart devices can be modeled from the programming point of view as actors. Basically, because we see a natural match between these smart devices and actors. For example, they do a particular task. For example, if we see one of the popular smart home devices like a smart radiator, the only job of the smart radiator is to control the temperature of a room. They also are isolated entities that only them can modify the state of the device, or in this case of the actor, and thanks to this isolation property, they can be easily distributed. However, although we see that this natural match between actors and smart devices, we also foresee a problem, and it's based due to the single method matching mechanisms that actors or modern actor languages support, where they basically can react to a single pattern. Let's show you an example of what kind of problem we can face. Let's consider this a smart home scenario where our protagonist, Harrison, wants to do some automation at his home whenever he arrives home. So basically, he has a setup of 3 smart devices, and he wants to know whenever he arrives home and do something. So whenever Harrison arrives home, there is a motion sensor in his front door that automatically sends a message or event to the smart home hub saying that a movement was detected in the front door. Right away, Harrison opens his door. There is also a contact door sensor in the top corner of the door that sends another event to the smart home saying that the front door was open. And right away, Harrison is walking into his entrance hall. There is another motion sensor that once again sends another event to the smart home hub saying that a movement was detected in the entrance hall. So far, the smart home has 3 events, and the only job of the smart home hub is to detect whether or not the messages were fired in the right order. And if the messages were fired in the right order, that in this case is the order that we just specified, well then the smart home hub can do something like using a smart speaker, welcome back Harrison, and say that a particular scene was activated. So this looks a very simple example where we have 3 actors, and if we consider the hub as an actor, we have 4 actors. And just a curious information that our inspiration for this setup is a real automation that I have at my apartment, where in this slide you can see the real devices that I'm using to detect this particular kind of sequence of events. So in order to see how complex can be to detect this event in a modern actor language, we opted to show you here an example, in this case, of the implementation of this hub in Elixir. And the first thing that we have to do is to define the kind of messages that actor can understand. And in order to do that, we use message patterns, we highlighted here, that each of these message patterns will match each of the events from the 3 devices that we are considering for this scenario. Just to give you an example, in Elixir, the message patterns are defined as a tuple where the attributes are composed by atom numbers or variables. Looking at this example, we can see that we as developers have to deal with several things, several concerns. For example, we have to keep track of the state because we need to react based on a sequence of events, not based on a single event. And this is a limitation of the actor model because they can only react to single events. And in order to solve that, we have to keep track, to keep that state, in order that later in the program we can reuse those events and check whether or not the right sequence was received or not. But also, we also have to determine if the messages arrive in the right order. And usually the only tools that we have is just compare using if, sometimes nested if, and that's the only way that we can do it so far. But the question here is that, okay, this was a simple example. What other requirements or concerns have to face the programmer to develop more complex automation? And in order to do that, what we did, and since we were focused on the smart home domain, we looked at the questions, the posts that users of the smart home community were asking online. For that, we consult 4 smart home community forums. And based on the kind of automation that they were trying to do, we processed several posts, and we end up with 7 automation examples that, from our point of view, they are, each of them represent a particular requirements that smart home user has to face or they need in order to automate their home. For this dissertation, we refocus on automation number 5. That you can be seeing this. You can see this automation as an extension of our introductional example, where we want to detect whenever the user arrives home, but also whenever the user leaves the home. This automation particularly has several requirements that you will see during this presentation. That was the main reason in order to keep it the same example of the presentation. We will use that automation. And now, probably most of you are asking, okay, but how do you know that the requirements of these 7 automation examples are representative in that community? In order to solve that question, what we did, okay, we once again used the online platforms of the smart home community, and we published an online poll where we basically map the scenarios of our automations to questions on that poll. And for example, here there is an example where we ask, I have automation that require to detect a particular sequence of events, and as an example, we use the one that we selected, that we end up in our automations. And in these ways, we were not asking about the particular automation that they wanted to do, but we were asking about the scenario where the users wanted to detect a particular sequence of events. So that poll was published in 4 smart home community forums. It was open during 30 days. At the end of this period, we collected votes from 714 voters from all over the world. And as you can see here, we were very happy of the results, because we can see, for example, that for question number 1, that is the need to correlate events from multiple sources, almost, more than 600 voters say that they need, this is a requirement that is very needed for the kind of automation that they wanted to do. But also, even if you go to the corner, to the question number 7, that's we also were expecting this kind of votes, because they target expensive devices that sometimes the API is not open, so the user cannot do more than the manufacturer provide. But it was almost 200 persons that say that indeed they need that. And we also, although we cannot do a statistical generalization of this online poll due to its nature, we think that our results are good because we don't went to a market and then start asking people that were there just buying food, do you want to do this kind of automation? No, this kind of users are experts that they are doing this kind of things. So we were very confident in the results. So what we did next was to, as I mentioned before, each of these automation has particular requirements. So we categorize those requirements, as you can see on the left of this slide, in 5 categories. And then here, just to give you a taste how these requirements map with our automation, we use colors to create this map between our categories and the ones of the examples. But once again, actors have been around for decades. So we knew that we were not the first researchers that were trying to solve these coordination problems between actors. So what we did next was to do a study of the related work. And we almost analyzed 50 approaches, 50 papers. Mostly all of these papers were focused on actor-based approaches. But since we were trying to do correlation of events, we also looked at the complex event processing system, what kind of things they were doing there, and then see which one of our requirements were already implemented in these kind of systems. Here is a summary, a general overview summary of our related work. And as you can see in the first 4 rows, those are the ones related to actor-based languages. There is almost a lack of most of the requirements in our study. That are the columns. However, we see that complex event processing systems have a better performance. In this case, it's not always perfect, but indeed they cover all of the 5 categories that we identified. So at this point, what we asked ourselves was, okay, how, since we were targeting actor-based languages, how we could integrate this programming language abstraction that satisfied this requirement, and as we found in our related work, study of related work, most of these requirements was already well known in the area of complex event processing system. And at the end, we came out with this nice language. It's called Sparrow. Well, that is a domain-specific language where developers can, in a declarative way, declare complex message combination to which an actor can respond, can react. So Sparrow can be seen as an actor language whose actors has been enriched with complex event processing ideas. And although we took inspiration from our smart home scenario, we consider Sparrow not a domain-specific language only for smart homes. It can be also applied to other domains, and even we tried some examples in the smart city domain, so they can be it can be applied to other domains. Just a second. To give you a taste of how a Sparrow program looks like, in this slide you see basic Sparrow program. In this case, once again, we are going to solve automation number 5. And the first thing that I wanted to do is to show you the main parts of a Sparrow program. In this case, the first thing that we as a developer have to do is to import the library of our language to our Elixir program, in this case, because Sparrow is a domain-specific language on top of Elixir. The second thing that we have to do is to define the actor interface, what kind of messages that actor will understand, and then we'll do that using patterns. The third one will be like what are the actions that will be executed whenever one of these patterns has a match, full match. And since we have patterns and reaction defined they are decoupled, we need a way to bind these two together, and then for that is the last block where using the React2 abstraction we can bind a pattern to a reaction, and in this way we have like a many-to-many relation where multiple patterns can share the same reaction, and the same reaction can be shared by multiple patterns. So now let's look more in detail to the implementation of this automation number 5. The first thing that we have to do is to define a pattern that will be like a general pattern, in this case that will handle motion event from any location in the room. However, the next two lines, we define 2 specific patterns. In this case, the first pattern from door motion will match motion events from the motion sensor in the front door, and the second one, the entrance hall motion sensor, will match messages from that particular sensor. We also have another pattern that will match, in this case, contactor contactor sensor messages. And after we have defined all these, let's call it basic pattern, we can then compose those patterns to detect the particular sequence of events that we want to detect, in this case, whenever the user arrives home and whenever the inhabitant of the house leaves home. We are assuming that only one person lives in the house. So, in this lines 9 and 10, here we see the implementation of the pattern that will detect the sequence of event to detect whenever the user arrives home. And as you can see here, again, we have the name of the pattern will be occupied home, and then we define that pattern as a conjunction of the 3 messages that we previously defined: the front door motion sensor, the front door contact, and the entrance hall motion sensor. But however, we added a constraint to this particular scenario because we don't want it to match all messages, so we wanted to match messages in a specific time window. And in this case, we added a constraint of 60 seconds, and this is one of the properties that we specified here for this pattern, that this pattern will match only if the 3 messages occur in a time window of 60 seconds. Second, we have to specify that the order in which the messages must match matters, and then by using the operator sequencing and setting the value to true, we say that the order in which the pattern, in which the messages have to occur in the same order in which they were declared. And finally, the last attribute is last true. In this case, we wanted always to use the last event in case that multiple events of the same type are available at some point. We always want to use the last message. In the same way, we do the same for the pattern to detect whenever the user leaves home. And we also wanted to highlight that reactions are basically, or they resemble a function from a functional programming language or a method from an object-oriented language. However, it has always three arguments. The first one is the list of messages that pattern matches. The second one is the dictionary of intermediate result in case that pattern did some transformation of the messages. And the last one is the actor state. The actor state, that is the way that we can update the state of the actor. Once again, here I just wanted to show you how, for this particular example, what are the requirements that we previously identified are represented in this example. Here I just wanted to say that it was too difficult to have one example that can showcase all the requirements. However, Sparrow abstraction support each of these 5 categories of synchronization requirements. At this point, in our research, we had a nice language with programming abstraction that can fulfill all these requirements. However, we wanted to do something else, like for example, try to allow other researchers to reuse our research. And in order to do that, we did a formalization of our language. We basically did it in 2 steps. The first step was we just write down all the rules, all the grammar, reduction rule of our language. However, usually when you write a formal specification of the language, you have to do some kind of proof. Sometimes you have to do, you prove some theorems. But another approach that is inspired by Felaisen in the paper around your research, you can do it by testing your formalization. And that was the approach that we took. So we did a mechanized implementation of Sparrow in PhD Redux. And by doing this implementation, we could test each of our abstraction and at least know that they were doing what they were supposed to do. For example, in this slide, you can see one of these transformations that we did from paper and pen to a mechanized model. In this case, on the left, you can see the reduction rule for the abstraction react to, the one that's bind a pattern to a reaction, in this case, PhD Redux, and that particular reduction rule, we can write an handwritten test to test it. In this case, this test arrow operator takes 2 arguments. The first one is the term that you want to reduce, that has an expression that can be reduced. In this case, the expression react to when you bind the pattern P1 and the reaction P1. But also the second argument is the result that you are expecting. In this way, Redux can specify or can check whether or not the reduction rule that we wrote were right or not, because at the end the 2 terms have to match. The problem here is that, as you can imagine, you cannot prove everything. So at some point you can do some tests, but then you don't consider all the options. So here we were like in this disadvantage. So, however, we knew that Redux already supports some kind of dynamic randomized testing library. It has a library where you can test particular grammars or predicates of your language. For example, here is just an example of how we can generate random terms that satisfy the expression PE, that is the one that defines a pattern. However, the limitation here is that although we can generate random patterns for messages, for patterns, for reaction, there was not a way to combine them. So that was not possible, and particularly for Sparrow, we needed that because patterns in Sparrow needed, for example, to react to more than 2 events or more than 2 messages in a particular type of window. So there were other requirements that were not possible to fulfill using the standard randomized test library provided by Redux. However, so what we did was to try to solve this issue by implementing our own randomized test library, in this case particularly focused for patterns. In order to do this, we had to do several things. The first thing that we have to do to create this interconnection between the different terms was to decompose the pattern. So each test will test only a single pattern, and in order to generate the messages that can satisfy or not that particular pattern, we have to decompose that pattern, like extract the selectors, guards, operators, all the components of a pattern. And in order to do that, we implemented recursive algorithms that do this kind of processing. And once we get all this information, then we can use that information to generate random sequences of messages. But usually, when you do the test, you test that a particular function, the result is true, so that they match the values that they were supposed to match. But we wanted to do a little more, and then we also wanted to check whether or not if we send or if we pass to that test an invalid sequence of messages, that at the end we will end with no activation for that particular pattern. So our library supports both, generates a valid sequence of messages, but also invalid sequence of messages. And by using this random sequence of messages at the end, the last step, we can generate a regex term that represents an actor that in this case will be composed by the pattern that we wanted to test, a dummy reaction that the only thing that we will do will be just to print the messages that that pattern matches, and the third one will be like a random sequence of messages that we just generated. So using this information, we could test our abstraction. However, the question at this point was, okay, how we can test that our implementation is correct? And in order to respond that, what we did is we have three properties. Our tests have three properties. The first one is that if we generate a valid sequence of messages, and we pass that valid sequence of messages to a particular test, the number of activation that that pattern can have at the end of the execution should be equal to the number of message sequences that we passed. So remember that the pattern only has a reaction, and whenever there is a match, there is an activation. So if we pass n number of sequence of messages, we should expect n number of activation. So that is the first property. The second one is that if we pass to the pattern an invalid sequence of messages, at the end we cannot get any activation for that particular pattern, so the number of activations should be 0. However, if we pass a valid or an invalid sequence of messages, whatever we pass to the test, the mailbox of the actor at the end of the execution should be empty. Only if these properties, or at least two of the properties are valid, then we consider that the pattern is successfully passed. So here is an example how we implemented this library. We have this abstraction pattern test, where the first argument that we pass is the language, in this case NES-T reduction. The second one, pattern, represent the pattern that in this case we wanted to test. And the last three arguments represent the first one, the number of sequence of messages that we wanted to generate, in this case 4,000 number of messages. You can imagine that if we wanted to generate 4,000 sequence of messages manually, it would be too hard to do it and would be too long. So here we can do it 4,000, 10,000, 100, whatever you want, you can do it. The next one, log output, refers to the number of information that you wanted to see as an output of the execution of that particular test, as you can see on the bottom in green. And the last one is just to say, okay, I want to generate a valid sequence of messages or an invalid sequence of messages. In the same way, so even when we have this pattern test abstraction, sometimes you want to debug your reduction rule and see all the reduction graph can be generated. So what we did, that was a feature from Regex, we extended that particular traces function in order to support our random messages. And here it's an example of how we can generate, or we can visualize the full reduction graph for this particular pattern using the traces abstraction of Redux, where you can see all the steps how the messages are being consumed and how the reaction are being fired. So, I have explained so far what is Sparrow, what problems Sparrow tries to solve, how other researchers can reuse our results by our formalization, and now here we wanted to talk more about what is behind Sparrow, how we support all this complex combination of messages, how we support that. And as I think I mentioned earlier, Sparrow is a domain-specific language that runs on top of Elixir. And a core component of Sparrow is called Jupyter, that is the pattern engine that supports all the magic that whenever new messages arrive, they check whether or not there is a pattern that can match or not. So in the next slide, I will talk more about this. I think that you already saw some of the main abstraction of Sparrow, like a pattern, reaction, and react to, but there is also two other remove and remove reaction, where the user can use to remove a particular reaction from a pattern or all the reaction of a particular pattern. All these abstractions were implemented as macros, and our main motivation to use it, beside the performance that we can get, the more clean code, it's because our host language, or the host language of Sparrow, Elixir, it's the main abstraction are also implemented as macros. If we look at our initial implementation to our introductional example, all def, receive, if, and operators are macros. So, and here, I just wanted to show you how a macro looks like in Elixir. So Elixir is meant to be a language that can be extended. So here is the declaration of unless operator, where using the quote and unquote expression, we can work with the abstract syntax tree of the program. Okay, as I mentioned, Jupyter is the core component of Sparrow. It's the one that handles all the matching that Sparrow actor can do. And what we did basically is that each actor usually have a mailbox that only can match single messages. What we did was to create a virtual mailbox that will be used by that pattern engine that then will use that virtual mailbox to detect the sequence of events. So basically, whenever a new message arrives to the inbox of the actor, we pass that message to the virtual inbox, and then after that, we feed that particular message to a discrimination network that will try to check whether or not there is a match. If we, at the end of this process, we have a match, then we will check that that particular pattern has a reaction. If that pattern has a reaction, we will try to execute those reactions. If not, we are going to discover that messages. However, as I mentioned, a pattern can have multiple reactions. As an actor can only, as actors are single-threaded, so multiple processes cannot modify the actual state. So what we did was to schedule the reactions. So one of the time, all the reactions that can be fired will be executed, and so in this way we can update the state of the actor without any issue. And on the left-hand side of this slide, you can see how this network looks like. Here, in this case, is the implementation of automation number 1 and number 2. And maybe some of you recognize that's something familiar, and yeah, indeed, all these pattern matching mechanisms is implemented as an extension of RITI, of the RITI algorithm. So we created some extra nodes, and we did some modification in order to fit our requirements, like a time constraint, negation, accumulation of arguments, but it's based on that idea of the RITI algorithm. So now we have arrived to the part, okay, how we evaluated our approach. And in this case, I have to say that this is a preliminary evaluation of our work. So we were mostly focused on the expressiveness of the language, and what we did was to implement the 7 scenarios in 4 platforms, including our domain-specific language. And by doing that, we were able to identify 4 main concerns that developer has to face to implement those automations. And what we did was basically manually each of these line of code that were related to each of these concerns, and after that we did a processing of those concerns, and that's what we used in order to evaluate the line of code, instead of just take the whole line of the number of line of code. So import, so all the code that was not related to the coordination process was omitted from this evaluation. And last thing that I wanted to say is that we as developer, the main goal is that we have to focus more on the pattern definition, so the logic that you want, the messages that you want to correlate, and the other ones can be handled by the runtime of the language. After we did this processing of each of the tags, here I just wanted to show you an example, and at the first side you will see that there are some colors missing or very small in Sparrow. Here we see that the solution of the same automation number 5 in Jython, in this case the OpenHub smartphone platform, and Elixir. And as you can see here, Sparrow programmer or developer doesn't have to worry about the stage management. That was one of the first problems that we identified early in our presentation, but also those related to the sequencing control and Windows management, they are always constant. They are always constant. However, on the other two solutions, the number of code or the amount of code that is required to do this particular task will grow and will vary depending of the number of events or actors that you wanted to correlate. Here, I just wanted to show like a summary of our results. We applied some descriptive statistic analysis over this data set that we collected from the line of code for each of these concerns that we identified. And in the first graph, this box plot showed the distribution of the line of codes that were involved in the execution or that were required for all these concerns for all the 7 solutions, in this case for each of the platform. And as you can see here, the 75% of the cases are domain-specific language have lower variability in its solution, but also more than the 50% is more than the 50% is more compact than the other solution. To see it in another way, using this radar share and using each of the axes as the 4 concerns that we identified, we can see that once again, Sparrow closer to the center is better. Sparrow is better almost in most of the concerns, except by the sequencing control, that in this case we were expecting that because only one of the automations were required that particular concern, and was also quite simple because it was an if that had only to compare 3 events. But as I mentioned, if you want to correlate to detect a sequence of 100 or even 10 or 20 events, that code will grow. So in this case, it will be like a big difference there. It's good to have a good language and with good programming abstractions, but also it's very important to have a good tooling support, because if you get frustrated because you don't have autocomplete, you don't have warning compilation warnings and all the things, you can get very frustrated. So we wanted to do something with that, not only for us as the language designer and developer of the language, but also for future researchers we could extend our work. So what we did was to extend an existing Visual Studio Code extension, in this case for the host language Elixir, in order to get this automatic and incremental static analysis with inline reporting of warning and errors at the time that the developer was coding. For example, here we can see how there is an auto-completion, and we wanted to create a new pattern, no motion, by extending a motion pattern. The problem here is that in that actor there is no motion pattern. Since there is no motion pattern, you will get an error saying, okay, there is no motion pattern there. However, if the developer fixed the error, in this case the right name was no motion sensor, then the error is gone. However, we went a bit further, so we also checked the properties of the patterns, and as you will see here, if by any chance the developer makes a mistake, in this case instead of Windows, he put instead of Windows he typed Windows, there is also, he can get an error he can get an error saying that okay, the window operator is not valid, or a negative pattern requires a time window constraint. So this was more about the developing, but we also wanted to support debugging our programs. And this is what we most focus for the developer of the language. In this case, we use another example for the smart city domain. Actually, this is a real example that was implemented in the city of Antwerp as a project of the City of Things that was developed by, was carried out by IMEC and Nokia as well. They did this automation in Mechelen, or in Antwerp. And so here the idea is that you want to inspect in real time how is your program behaving, how are the actors, what kind of messages the actors already matches, or what is the current state, the number of activation. And you can do that by just simply typing the command that is on the right bottom of this slide that we implemented. And then right away you will get this nice graph where the developer can click each of the nodes. In this case, that program only has one actor, but you can imagine the program can have multiple actors, and then you can see how many messages a particular node has already matched. You can see the number of activation. If it is a join pattern, you can check each of the clauses, and you can see all this information in real time. Of course, there is a cost, but this is just meant for debugging purposes. When the application is in production, that features will not impact the performance of the application. But also, you can imagine that you have a big application. Sometimes you need some tools to see all the nodes, how the nodes are connected, input and output nodes. We also supported this leader feature in order to improve the usability of this particular monitor. Okay, we are arriving to the conclusions. I think that I'm on time. So far, in this dissertation, we have identified a set of synchronization requirements that we can face in order to develop modern actor-based applications, in this case, smart home applications. We also demonstrated that there is no actor language that has like a full cover of all these requirements. However, we found that complex event processing language have a better support. So what we did was to integrate, to borrow those ideas from the complex event processing domain into an actor language. In this case, we developed Sparrow. To facilitate the reusability of our work, we developed a formalization of our language that not only provided the paper and pen solution, but also mechanized solution that we can test, we can run, and we can add new features and see if they were working as expected or not. That we call it Nest. To support the detection of complex combination of events, we extended the RITI algorithm to embed this algorithm in each of the actors. So that's a distinctive property of our implementation, because usually we found that this kind of RIT implementation are usually globally, like the whole application share a single engine. In this case, each actor has his own engine. To validate our proposal, we did an initial evaluation based on the expressiveness of our language. Basically what we did was the implementation of our 7 examples in 4 platforms, and then detect how well this platform tackle each of the concerns that we identified during the implementation. And finally, to support the development of Sparrow application and also the extension in the feature of this language, we developed a Visual Studio Code extension and also a monitor tool that can inspect in real time the state of the actors of the program. Thank you so much.
Thank you for this presentation. I think it was a very accessible presentation, but nevertheless, I'm sure there will be some questions. So let me first invite our external committee member, Professor Siguru Shiba to ask some questions.
Just a minute. Yes.
Oh, okay.
Yeah, now. Yes, sorry, it was moved to the laptop.
Okay. So I think first of all, the work is very interesting and very impressive. It covers, from the design, software design, and also semantics, and also toolchain. That's the last part is very nice. I really impressed. Because it supports very nice toolchain, I have a question about the debugging.
Yeah.
Well, I understand your system support provides very nice debugging tools, but I think the target users of this language is non-experts. That's what I understood. So for them, I wonder. Well, your language supports very nice pattern matching, but I wonder for those non-expert programmers, thinking about kind of consistent pattern matching might not be easy. Well, yes, your debugging tool tells them if their patterns is wrong, maybe the semantics analyzer or debugger shows that is wrong. For instance, two different patterns have some overlaps and so some sort of make some inconsistency. But that's nice, but from the viewpoint of the end user and non-expert programmers, they might want to see more kind of suggestions how to solve, how to achieve what they want to do. I mean, expressed by natural languages in a very ambiguous way. So I wonder if you have any ideas about kind of debugging support, the programming support for those non-expert users I would like to hear.
Yeah.
So what about that?
Oh, okay. Yes. Well, the first thing that I should say is that one of the main motivations that we developed Sparrow, and also because why we choose for this smart home use case was the frustration, personally, and also well in the context of the research, that when I was trying to do these kind of automations at my place. So yeah, indeed, Sparrow is Sparrow targets end users that are advanced programmers. Those are the kind of users that use this open app, home assistant. So that kind of user are the one that gets their hands dirty, let's say that way, trying to do more things that you can do usually when you use a SmartThing app on your smartphone or a home app from Apple on your smartphone or your on your smartphone. So the kind of the automation that you can do there, they are very limited. That's why we took like a text language approach to try to do more things. But indeed, maybe can be like possibility that in the future we can provide some kind of visual language that can map from that visual abstraction, let's say Scratch in that way, to our advanced text based language, in this case Sparrow, and then we can do more. And then for those users, end users that they are not experts, they are not programmer expert, then they can use it program. But the current version of our domain specific language don't target this kind of user. It targets advanced programmers, or at least people with knowledge of programming that know that they need, they want to do more things than the one that in this case you can do using a simple application. But yeah, indeed that could be nowadays. Everyone or the industry is moving more and more to this visual language. Maybe that can be a possibility for the future. But so far we were just focused on that particular user, the ones that can program. I don't know if that's
okay. So maybe,
yeah. Okay.
yeah, maybe rephrase my question. So, okay, so you see a little bit more experienced developers. But
Yeah.
even for them, it might be difficult to come up with the right description of a bunch of event filters to satisfy, to achieve kind of complex things. Do you have, I think you have a good experience of using this language, right? But I'm curious whether you think writing program is basically easy, or even for you, writing Sparrow code is not straightforward.
I think that to facilitate the usability of Sparrow and then understand how Sparrow works internally, that was one of the main motivations that we developed the monitor tool, because in that way you can get not you can have like the pattern that you wrote, but also you can have the visual representation of that pattern, and then you can inspect how that pattern is distributed around your actor, and then you can check each of the components, each of the properties, and see if they behave or not in the way that you were expected. That at least was our solution in order to facilitate us, but also new people that can understand how Sparrow internally works. And as you saw, this is a tool just basically to visualize. It's not to edit, to put like a breakpoint. It's very simple tool just to inspect how is your program behaving. But yeah, we can do more things,
okay.
for sure that we can do more things to improve this area. But it's not my expertise.
Okay. Thank you.
Do you still have another question, or can we move on to the other external committee member?
That's it.
Fine.
That's it.
Yeah.
I
Okay.
stop.
You're satisfied.
Yeah.
Okay. Then we move to Tim for a follow-up question.
Yeah, at first, thanks for the great presentation. I can also only agree with Shiba. I really like that you thought about tooling. This too often gets forgotten in these short times that PhD have for like writing a new language and all of this stuff. And then thinking about tooling is great. My question is about the operators that you demonstrated, sequence and window in your presentation. And there's more in your dissertation, and we could imagine there could be more in the future if other researchers continue this language. And so these operators, I mean, you can kind of compose them, and you can use inversions on them, but maybe sometimes it might get confusing if you have many operators and then you use not, for example, to invert what an operator is supposed to mean. So what were your kind of guiding ideas? When did you think now you should add an operator versus maybe you should make an operator specific for a problem versus having something that composes with another operator? And also in the future, if you imagine this language to continue and you have more problems beyond these initial 7 or so problems that you based some of your examples on, what would be like? What do you feel would be like guiding principles for these operators? Should they become like really composable, or should they be like more specific so that it's maybe more helpful for novice programmers? Because I find that generally, if you have more specific operators, there's the one thing that you can tell a novice programmer, use this operator, and then it does exactly what you want. Versus if you start composing things, the programmer has to think about it a bit more, but it might come with more power. So yeah.
Yes. Yeah, indeed. You are right. So for some scenarios, maybe could be useful to have like a more specific operators. If you want to use Sparrow for a very particular domain, but our goal let's try to define the basic ones that we can have, and then that we can compose, and then we can solve using those basic ones most of the problems that we found during our research. But yeah, so far we target these particular, like more general purposes operators that you can compose. But yeah, indeed, if you start to composing, at some point will get messy. So maybe at that point, if you frequently end doing these kind of things, maybe it will be the best to develop a particular operator that satisfies this kind of problem that you want to solve. But as language designer, we just try to do it more general possible, and then those are the ones that we found based on our experience, based on the things that we found online. But indeed, maybe the case that there is another one, two, or even more that can be added. But then I think that will be part of the domain where you want to apply the language. But so far, at least we tried for smart homes, for smart cities, like a real project, as I mentioned, the one that we use for the monitor tool, real project that they were implemented here in Belgium, in Antwerp, and we were able to implement them using our operators. I don't know if that's enough for you, satisfied?
Well, one tiny follow-up. So since you arrived at that conclusion, are there any operators that you considered but didn't put in, just like out of interest, or are there any in right now that you kind of think now might not have been necessary? Just out of curiosity.
Well, we have fold and map. You can create a map using the fold. That can be the map maybe can be removed, but then at some point we found that the map was like recurrent, the thing that we wanted to do, and then that's why we decided to add the map. But then maybe we can add in the future reduce or another one. But yeah, and if you ask me which one I could remove, for example, we can remove map, and then we can do it with the fold. That will generate more work.
Yeah. I mean, it's always this design questions are always about balancing convenience and usability. Yeah. Thanks. That's. I think I'm good with questions.
Okay, thank you. Then maybe we move to Theodore. Yeah?
Ladies first.
Oh, ladies first. Lisa. Christina, please.
Yes, thank you very much. Yeah,
I have to
speak up. Thank you very much for your presentation. I'm not a specialist in this topic, let's say, but you say that for your language you need to be an expert programmer.
Yes.
So I was wondering, people who today use OpenHub, would they find it then easier to use your tool, or would they be a bit hampered by the fact that they are used to another system?
Well, yes. Let's rephrase something. Sparrow, it doesn't have to be like a super expert programmer, but it has to be someone with knowledge of programming. It's not like, I don't know, maybe someone in the room that doesn't have any knowledge of programming, have some smart devices at home to control, I don't know.
Yes.
So it's just like clicking and moving things. You can do some automations, or just selecting options from the combo box. That's the easy way, yeah? But then we target programmers.
I understand.
So, and the second one, yeah, I have been involved in one of the platforms that we took for our work, and particularly for one of the projects that you can write more advanced rules for home assistant. It's called Updable. And since I have been in that community, like a contributor, one of the main contributors of that project, I have been involved with members, and I have shown Sparrow and then asked them, okay, what do you think? Do you think that this is real, that this is expressive? Look how do we do it in Python. This is the language that program uses. And then indeed I have some good feedback from them, but I cannot say like it's a wide community or too many persons. It's just like a niche, let's say, like a small group of colleagues, let's say, that I have shown the research, because again it's research. So, but yeah, I had a good feedback. One of the questions that I got from one of them was, okay, it would be good if you can have that expressiveness, but using also mapping from a visual language. So nowadays everyone wants to do something dragging things with a visual language, and then that was one of the questions that apparently seems like open. Okay, can you do something with a visual language? And indeed, maybe we can do it. In the past, we have experience doing this kind of things, like to build blocks to control a drone and then translate that blocks to JavaScript or another, so that maybe that a child can control the drone without programming knowledge. So that can be possible.
Okay, thank you.
Yep.
Next, Theo.
Thank you, Humberto. Really nice. So I had a look at the notes I took for writing defense to refresh my memory.
Yeah.
And I noted that at least 4 occasions I put in the margin an annotation GC question mark. So to a certain extent that's because I have garbage collection on the lines. Yeah. But there's some basis for that. So I was actually wondering, because you hang on to quite a bit of historical information, and you try to control that with time margins and deadlines and time limits and stuff like that. And I was wondering how you can always control the impact of that. Because you have a DSL on top of a language.
Yes.
And that means that you depend on the idiosyncrasies of that language without always having control over it. Yeah? So, how scalable is this approach? So, if your system, if your application becomes really big and you make mistakes in establishing time intervals and deadlines and so on, can't you get into a phenomenon that's called thrashing? Yeah, where the overhead is bigger than the actual processing?
Yes, indeed. As since Sparrow runs on top of Elixir, and Elixir on top of the Beam, the Erlang virtual machine, we have that problem because the size of the mailbox is just the memory that the computer has available at that time. So we did something, not big things, but since we have this virtual mailbox, in that virtual mailbox, by default, each message has a time to live by default. So after that particular time, if the pattern that is interested in that particular message doesn't have another or a different, shorter or a bigger time window, that message is automatically garbage collected by the pattern engine. Runtime will be automatically removed. But indeed, if you don't know the rate in which the messages will arrive, and you don't know the resources that you have at your in your PC, at some point the program will crash. What we did, or what we have now, is that we will respawn that actor, but that's like recovering from crashes is not implemented. But we have this supervision tree that we inherited from Elixir, so that we spawn that new actor. But in this case, that is a problem. That's one of the things that Thierry's PhD wanted to tackle. But at that, for his case, he knew in advance the rate, and then based on that rate that he was expecting, he can do some calculation. Okay, for this particular application, I need this hardware with this memory. This is the main consumption that we have here, that we have in Sparrow because of our rate implementation. But however, even when we have all this abstraction on top, I think that we do pretty well. Here is just a preliminary benchmark, not ideal setup, just running each of our implementations. In this case, in Elixir, because it's the host language of Sparrow. And in the Sparrow, and you can see that, yeah, indeed, there is an overhead, but it's always or almost or is usually constant. So there is not like a peaks that grows. So I think that at least for this automation, that they are not too complex automations, the performance was okay. At least I can put up an event, I can see that the lights turn on without waiting, and then, okay, yeah, now 5 minutes later, the light was on. So it was like acceptable from my point of view, from my user experience. But yeah, we have to do more. As I mentioned, that we were not focused on performance, and it was like iteration, so we wanted to do things. I think that maybe if tomorrow I look at the code that I wrote over this year, I can do some tuning and I can get better performance. And maybe if I can do that, I can do like try to do a startup or something if there is someone interested in this kind of technology. Let's see.
Okay.
So, Humberto, maybe I can also ask a question.
Yeah, sure.
You told us during the presentation that your debugging tools and that later on you turn it off, so to say, and it doesn't hinder the performance of the code once it's deployed. But yeah, real life never really behaves as expected. So I was wondering, would it be easy to use this tool as a kind of logging tool? So suppose, and the way I imagine the world is not.
Yes. Basically, what I'm using to show all this information is some kind of login. And at some point, the idea was that since we have all these logs of all the operations, we can like backtracking and then see how we arrived to that particular state of the actor. We didn't did it at the end, but then we have these kind of logs that can be used, and since we are using macros, that's what was about the thing that I mentioned earlier, we can remove that code from the final code, the production code, and then there is not impact in the performance because it's the same. So again, in the same way that we took inspiration from Elixir does the same for its login library. They do the same. So you can have logs all over your code, and then when you say, okay, this is production code, all this code will be removed from the final bytecode that we will use.
Yeah, but you can easily reactivate it
if
you want to. Okay, that's interesting. The promoters, do they have a question? No? Then I will invite the public. I don't know if there's a chat possibility for the online people. Yes?
Yeah, so thank you for the presentation. That was really nice. I had a question about your slide 12. You seem to focus a lot on composing messages into patterns and abstracting away unnecessary information.
This one?
Yes. But what I'm wondering about is, you seem to go all out on information hiding. For instance, if you look at line 9, there is an occupied home pattern, but it's composed of several messages, and I wonder whether you can still later on access the payload of those messages.
Yes. You can still, for example, you can attach a reaction to the front door motion sensor, and then you can do a complete different thing from the one that can do the occupied home pattern. So you can access to that information. It's already there. It's just a way like we could rewrite that pattern number 9 just by declaring inline all the patterns, and in that way that will be not possible to access to that payload. But since we are like composing, reusing previously defined patterns, we can do it. We can attach a reaction to the patterns from line 4 to 6 to 7. We can attach other reactions, and then those messages will be consumed by those reactions.
Another question. I don't know if there was one in the chat.
Yeah, I have a question
Okay, perfect.
from the chat from Florian. I will read it. So, IoT and home automation application are good fit for visual programming environments, both architectural perspective as well as from the user perspective, enabling non-technical homeowners to implement or customize their own application. Testimony to these are such systems as Nico Home Control. Do you think that Sparrow could serve as backend for a graphical general purpose domotic language? What construct of Sparrow would be the hardest or impossible to translate visually? Okay, to the first question, yeah, I think that maybe that's a possibility that we can explore in the coming near future to see if how these companies are, or what kind of languages they are using, what is their backend, and maybe in principle we could use, because at the end they consume events and we do the same, and then based on how they consume the event, how they detected patterns, they do some actions, and we do the same. So to the question, the answer to that question, yes, I think that the Sparrow could be fit for this industrial robotic systems. And the second one is what kind of construct will be the hardest or impossible to translate visually. I think that indeed, if we do it, we create a visual language, at some point we will lose the expressiveness that we have now with text-based language. And I don't know. So far, the visual languages that we know to do all they don't have pattern matching. For example, that's one thing that we heavily relied on. And visual languages they just use if, and then they have to do if this and this and this and this. They have to do that. So that pattern matching will be something that will be at least the knowledge that I have will be hard if not impossible to do. Lisa wanted me to repeat the question. So the question was if I think that the Sparrow could serve as backend for a general purpose domotics language that's as the one that have been used by companies like Nico. And my answer to that question was that yes, because I expect, or I suppose that we share the same architectural, consume events, and then react to those events. And the second question was what constructs of our domain-specific language would be the hardest or impossible to translate visually. And for that, basically one that came to my mind right now is the pattern matching. That will be quite hard to do it, if not impossible.
Okay, so if there is no more question, another one?
Yes.
So that's the last one then? Huh?
So I have a question from Kennedy that says, can you comment on how Sparrow provides this, wait a second. A key aspect of complex event processing system is conflict resolution. Yeah, this affects the order of similar rule instantiation. Can you comment on how Sparrow provides this for patterns and reaction, or if not? So for conflict resolution, we don't tackle conflict resolution. The only thing that we do is that we base
if a pattern has 3 reactions, we execute those reactions in the same order that they were attached to the pattern. So we don't have any order that you can specify, okay, this reaction or this pattern has to be executed first than this one. So far, we don't have that. We basically have a fully locally but also distributed actor-based engine that each of these nodes are executing concurrently, so we cannot control that. So we sacrifice that scalability, let's say, for the pattern engine, but then we don't tackle that conflict resolution.
Okay, I think we can conclude here, and if there are more questions, people can always ask them to you later on.
Okay.
I think we have enough to conclude here. So the committee will read it out now. So those who are committee members who are remotely, they will receive a Zoom link to join the deliberation. So we will go to another room and we'll come back soon.
Okay.
Dit jaar is rap, hè. We moeten maar vandaag klaar zijn met zijn teksten schrijven. Ja, ik zou dit jaar klaar moeten zijn, maar no way, het gaat gebeuren. Ja, maar dan moet binnen de tekst af zijn, dan in december de enige dat mij niet gaat afzetten. Ja, daarom als je alles optelt en dan vakantieperiode in december, dat is no way dat het gaat. Nee, tot 1 januari loopt het af. Ja, nog 1 jaar geleden. Dat kan zijn, ja, ik weet het niet. Ja, sowieso wel. Ja, hij is ook begonnen in de voorbeeld. Dus de gewoon van ja, ik heb nog een jaar aan tekst van wel. Dat is een eerste 4 jaar en 3. Nou ja, je bent een Twitterman. Basically, letterlijk in de lineaire druk, dat constant is, weinig is constant. Ja, als je zo'n heel lineair is, dan constant. Dat is geen punt. Dan is het je kunt dat reduceren, een chapter op 2 pagina's kunnen reduceren naar 1 paragraaf. Wat triviaal is. Benchmarks in dat
now give the word to Christina, our secretary, who will read the conclusion of the committee.
in Dutch to you. It's about een doctoraat in de wetenschappen met proclamatiedatum 24 augustus 2021. Deze zitting staat onder het voorzitterschap van professor Annooy, met mezelf Christenat als secretaris. En wij hebben de aanwezige leden van de examencommissie, promotoren, professor Wolfgang de Meuter en co-promotor professor Juri de Koster. De leden van de jury, professor Theodon, professor Shigeru Shiba of the University of Tokyo, Japan, en professor Tim Velgentrefte from Oracle Labs Berlin, Germany, Duitsland. Wij hebben natuurlijk ook aanwezig onze promovendus, Humberto Rodriguez Alba, die regelmatig is ingeschreven en voldoet aan de vereisten om dit examen af te leggen. Hij houdt in het openbaar een uiteenzetting over zijn proefschrift, getiteld Orchestration of Actor-Based Languages for Cyber-Physical Systems. De examencommissie beslist na beraadslaging dat hij heeft verdiend de graad van doctoraat in de wetenschap. Congratulations.
We don't have grades anymore, so it's a pass or a failure. It's for clear a pass, so very well done. I think the external committee members want to address a few words to you. For one of them, it's already late in the evening, so we could give them priority to do so.
Unmute maybe.
Yes.
Yeah, now.
Can you try to say a few words?
Maybe your speakers are muted.
No, not anymore. Hello? Hello?
You might not realize.
Hello.
I can hear Shiva.
Yes,
Hi.
we do.
Okay. Yeah, congratulations. That's it. I really enjoyed your talk, and also reading your thesis was very fun. So, congratulations.
Thank you.
And very well-rounded thesis. It's really nice. It's a really good read.
Thank you.
Well done.
Maybe the promoters, I don't know. Did you prepare something, or
Yes.
can you keep it for later? Or?
I don't know, no. I always say something, this is where my work ends, we are now on the same level. So I typically give a final message to the candidate, and I typically do that in the language of the candidate, which is today Cubano. This is my example. So, la entrada de Humberto en la VUB siempre me recuerda en una obra de un comediante belga llamado Urbanus Fananes, que sería en español algo como Vano del culo. En la obra, el comediante habla acerca de los chicos del Giro, una organización de chicas flamencas, y la broma es acerca de que una de las chicas está cogiendo botella, autostop, al lado de la carretera. Pero tan pronto como tú paras el vehículo, 19 de ellas aparecen detrás de los arbustos y de momento tiene 20 mujeres en tu carro. Al final, Urbano del Culo le dice a su audiencia que él es muy feliz con todas esas mujeres. Humberto interpretó precisamente el papel de la primera chica. Él se puso en contacto conmigo en 2014 a través de correo electrónico para ver si podemos colaborar. Coincidentemente, eso fue 4 semanas antes de que yo viajara a Cuba en el contexto del proyecto de Anne. Yo estuve de acuerdo en buscar financiamiento para su PhD. Y de momento teníamos 5 estudiantes de doctorado de Cuba en Soft. Pero como Urbano del Culo, estamos muy felices con todos ellos. Personalmente estoy muy feliz de haber parado por él. Humberto es extremadamente laborioso y muy bueno en todo lo que hace. Él es uno de los pocos estudiantes de doctorado en mi carrera que es bueno tanto en la teoría como en el trabajo práctico. Esto también se manifiesta en su trabajo. Humberto también tiene muy buen olfato para la innovación genial. Casi todos los años Humberto ha propuesto tesis de grado y de maestría basadas en nuevos juguetes electrónicos que ha encontrado en Internet. Personas como Humberto son la fuente de nueva entrada intelectual en cualquier organización, y cualquier compañía que se encuentre con Humberto obtendrá los beneficios de ello. Terminaré mi discurso. Ahora, felicidades una vez más. Si por alguna casualidad tienes más cubanos ocultos entre los arbustos, dínoslo. Basado en nuestra experiencia, este Urbano del Culo estará feliz de acomodarnos en su auto.
Now is my time. Yes. Okay, well, I would like to thank all of you first for being here today. I would like to thank the jury members for their comments, their time for reading my PhD. I would like to thank my promoters, Wolf, Judy. It has been like a long journey, a lot of brainstorms, a lot of changes, so several iterations, but then at the end I think that we got a result that we are proud. I would like to thank to Elisa, that she was at the beginning of the PhD of helping me. I would like to thank to all softies, current ones, the ones that are not with us anymore, for all the feedback that at some point they provide me during the research presentation, during the Rebels meeting. I also would like to thank to our secretaries that they have been always for me, not only to deal with academic matters, but also with all personal, like calling to get in time the residence permit and all the things. They were always for me. Thanks, Lara, for all the calls that you made. I would like to thank to all my friends. I have a lot of friends. I don't want to say names because I will miss one, but the new friends that I have met here in Belgium, those in Cuba, and those that are all around the world here, we have like a good representation, and I'm very happy for that. I would like to thank also to my family. They cannot be here for many reasons, but muchas gracias a mi familia, a mis amigos. Yeah, I think that there is more to come. So we can glad. Merci Morales. I would like now to invite you, all of you, to the reception in the complex, and then after that, I think that the weather should be still nice. We have a barbecue, so now party time.